Good morning, my dear students. I hope you are doing fine. In previous classes, you have started your atoms and molecules chapter, which was your third chapter. In previous classes, we have learned that what is the law of combination and what is the law of constant proportion. And after that, you have learned Dalton theory and postulates of Dalton theory. In today's class, we will going to discuss about atoms and how to represent these symbols of elements with this atomic mass unit. So first thing, what is atom? Atom means it is the tiny part of the element. The smallest particle of the element is called as the atoms. They may not or maybe exist independently and retains all its chemical properties. So what is atoms? Atoms is the smallest particle of the element. First thing is, what is atoms? Atoms is the definition of atoms. Atoms is smallest particle of the element. Atoms is the smallest particle of element which may or may not be exist independently. Element that which may or may not be exist independently. So this is the common definition of atoms, that atoms is the smallest particles of elements that which may or may not be exist independently and retains its chemical properties and retains its all chemical properties. It means each atom have a equal properties. The elements is consisting of metals and the smallest particle or smallest tiny particle is of the element is atom, which may or may not be exist independently and retains its all chemical properties. So this is the common definition of atoms. Now, next thing, which already we have discussed in previous classes, that atoms are very small in size and smaller than anything we can ignore or compare with. It means the atoms have so much tiny particles that you cannot see by your naked eyes. It is invisible, so you cannot recognize also that where is the atom is exist. So atom is a very small in size. Atoms are small in size. Next, the atomic radius of the hydrogen ion is 10 raised to minus 10 meter. What do you mean by this? Example of the atoms. As I told, the hydrogen atom consists of lots of atoms. The atomic radius of atom of the hydrogen is 10 meter. Atoms of hydrogen, atomic radius, the atomic radius hydrogen is 10 raised to minus 9 nanometer. So you can imagine that how much small is the radius of this hydrogen atom. So these are the basic points of atoms. That atoms is the smallest particles of element that which may or may not exist independently and retains its all chemical properties. Atoms are small in size. Simple example I am giving you. The atomic radius of hydrogen atom is 10 raised to minus 9 meter. Now we have so many elements. The elements, how you are going to represent it? The first question, so many elements are there present in our nature, how you are going to represent it? You have to represent it by the symbols. Which symbols? In our ancient time, in our ancient scientists, what they have done, they have given the name of each and every elements, and using the capital letters they have represent the elements. So now we are going to discuss about the symbols of atoms of different elements. In previous classes you have used many things: chlorine, iodine, barium, bromine. Where it is come from? How it is formed? Who gave the name as barium? Who gave the name as bromine? So these are the elements which is named by our scientists. They have done periodic table in a ascending order. So on the basis of chemical properties, on the basis of physical properties, on the basis of decreasing order. So they have collected all those properties and arranged in a periodic table. We have so many elements. So few of the elements we are going to discuss now, and how to represent these elements by the symbols of capital letters, which we are going to discuss now. Symbols of atoms of elements. While giving the name of elements, the symbol of letters are represented by the first letter. For example, hydrogen. The name of the element is hydrogen. So what is the first letter of hydrogen? That is H. So how you are going to represent this hydrogen? H. This is one of the element. Next, for example, next is nitrogen. Here certain examples I am taking, so you get an idea about how to represent the elements. Nitrogen, how you are going to represent? With the help of capital letter N. Third one is carbon. Yes, carbon. How you are going to represent the carbon? C. Next example, oxygen, represented by O. Next, another example we can take here, iodine, represented by Aluminium. And next is argon. So these letters are same, A and A. So in this condition, next letter we have to give preference for that. We have to prefer second letter, like aluminium is represented by Al. Aluminium is represented by Al and argon is represented by Ar. Ar. Next example I am taking here, barium and bromine. So here B, we are same, right here B, here A, that is represented by barium, bromine is Br. Next is calcium. So another example is chlorine. As you can see here, C same, but next is different. Here calcium is represented by Ca and here H can be ignored and you have to take here that chlorine represented as Cl. We have some few examples that it is not represented by their names. It is represented by the other names. Which are those? Like iron. It is also called as a ferrous. So this is represented by Fe. Next is gold. This is not represented by Geo. It is represented by Au. Aorus. Next is silver. It is represented by Ag. Here some few examples are there which is not represented by their capital letters. Next is lead, which is represented by Pb. Next is potassium. Which is represented by K. So what is the meaning of how you are going to symbolize the elements? First you have to prefer capital letters of first letter. Then here few of the examples in these conditions, the first letters are same, so that's why we have to prefer second letter of this element. So that's why aluminium is represented by Al, argon is represented by Ar, barium is represented by Ba, bromine is represented by Br, calcium is represented by Ca, chlorine is represented by Cl, and we have some few examples in that capital letter is not going to prefer here. So iron is represented by Fe, gold is represented by Au, silver is represented by Ag, lead is represented by Pb, and potassium is represented by K. So these are the symbols of atoms of the elements. Now next is atomic mass unit. How you are going to weight the atoms? This is the main question. You know atoms is a very tiny particles. Those are in a smaller size. But how you are going to weight the atoms? If you are going to weigh something in a shop, weighing machines are there. So simply you will go there and weigh the things, and you can say that no, this is 1 kg, this is something gram. But atoms you cannot weigh. Why? Because it is a very tiny particle. You cannot hold also, you cannot see also. So that which already we have discussed, he gave some postulates about the atoms. He suggested that, he invented that how we can represent the two atoms. Normally, if you want to weigh something, you go directly to the weighing machine, weigh that, and finally you got the answer. No, it is this much of amount. But what about the atoms? We cannot hold it. As I told you, we cannot weigh this and hold it. So, how you are going to weigh these atoms? Dalton suggested ratio method. He suggested that if we are taking the two numbers of atoms, it means if we are comparing two atoms, this is the weighing machine, suppose this is the weighing machine and this is the atoms. If you are going to tally this, then you can consider this is this value of atoms, because we don't have option to weigh this. So that's why what we suggested, comparing method by using the standard unit. What is the standard unit of atoms to weigh this? The standard units which he had learned about carbon. First he was interested into hydrogen, because hydrogen is the lightest particle which is present in our nature, because the atomic mass of unit or atomic mass of the hydrogen is around 1 point something, which is the least highest particles. It is a very light in weight. So next he went to the carbon. What he suggested, 1/12 part of the carbon is become as a standard unit. Why? Because carbon is the most consistent and dependable standard of the calculating atomic mass. As you know that it is a very small and very difficult to find out the value of atomic mass. That's why Dalton suggested this method for comparing the ratio among the atoms. And he suggested to prefer carbon because the carbon is the most consistent and dependable standard for calculating atomic mass. Why is carbon preferable? Carbon is most consistent atom to prefer atomic mass unit. He gave the standard rate of comparing the atomic mass unit. He suggested that the 1/12 part of the carbon can be become as a atomic mass unit, or you can say that the 1U. What do you mean by U here? It is unified mass. It is a unified mass. In So here 1 U means it is a unified mass. How you are going to calculate this carbon atom? First thing, then only you can get the other values of atoms. So 1 U is equals to first thing that you have to calculate the 1/12 part of the carbon. Then only you can get the value of any one of the elements. So 1 U is equals to 1.9 into 10 raised to 23 divided by 12, because it is a 12th part of the carbon. So 1 U is equals to, if you are going to calculate this value, 1 U is equals to, it becomes 1.66 into 10 raised to minus 24 atomic mass unit, or 1.66 into 10 raised to minus 24 unified mass. This is the standard value which you have to compare with the other atoms. So here one term will come that it will be helpful for you calculating the relative atomic mass unit. So what is the relative atomic mass? It is the ratio of, or it is the average of the mass of one atom to the one unified mass, or 1/12 part of the carbon. Okay? So how you are going to define the relative atomic mass? Relative atomic mass it is the ratio. This is the ratio of mass of one atom. Any one of the element, you can take the mass of that atom and you have to calculate, or you have to divide by the standard unit, that is 1.66 or 1/12 part of the carbon. This is the 1/12 part of the carbon. The value of 1/12 part of the carbon is 1.66 into 10 raised to minus 24. So that's why we are able to understand the things, or we are able to weigh the mass of the atom. So mass of one atom, mass of an atom divided by 1 U, or 1.66 into 20, 1.66 into 10 raised to minus 24 unit. So this is our formula to calculate the mass of any of the elements, or you can say is the relative atomic mass, which helps to calculate the mass of any one of the element. Now we will going to take one example, so you will get an idea how to calculate the mass of the atoms. Suppose one example, that is hydrogen. So what is the value of, or what is the weight of hydrogen? It is around 1.6 into 10 raised to minus 24 grams. This is the weight of hydrogen. How you are going to calculate relative mass of the unit? Relative atomic mass, that is 1.6 into 10 raised to minus 24 divided by 1 unified mass, or 1.66 into 10 raised to minus 24. So what is the value now? It is a 1 atomic mass unit, or 1 U. You got the value of hydrogen, or weight of the hydrogen. Next is oxygen. It is 2.66 into 10 raised to minus 23 divided by 1.66 into 10 raised to minus 24. The result will be around 16 unit or 16 unified mass. 16 unified mass or 16 atomic mass unit. So this is the concept of to calculating the atomic mass unit. In next class we will going to learn that it is possible to calculate the molecules. Yes, on the basis of